Hi, everyone. Thanks for joining. We'll start at the top of the hour. We apologize for technical difficulties. We somehow had us set half an hour earlier, but we'll go 4 to 5 Eastern Time. Right, so we're at the top of the hour, so let's go ahead and get started. My name is Julia Matevosyan. I'm Associate Director and Chief Engineer at Energy Systems Integration Group, or ESIG. I would like to welcome you all to ESIG Large Load Task Force Kickoff webinar. First of all, let me give you some background about ESIG. For those of you not familiar with ESIG, we're a membership-based nonprofit organization providing our members with objective information, resources, and networking opportunities in support of energy transition. We do this through workshops, tutorials, webinars, blogs, working groups, and task force activities, and producing technical resource materials. Large Loads Task Force is the newest ESIG task force that we are kicking off today. And so I'm glad you joined. If you are new to ESIG and you would like to hear more about us, I strongly encourage you to follow up with us. And I think you will be pleasantly surprised. ESIG membership will give you an opportunity to participate actively in all of our working groups and task forces, including this new Large Loads Task Force. You can find us on the web at www.esig.energy, as well as LinkedIn, Facebook, Twitter, and YouTube. Further information about ESIG can be found on our webpage. If you are interested in joining this large load task force, as you're listening to the webinar today, please fill in the survey. It will be posted now in the chat. Note that Large Loads Task Force is member-only activity. If you are not yet ESIG member and you would like to join, please follow up with us after the webinar. In the survey, there is a chance to choose which of the topics of the Large Loads Task Force you are interested in. So please fill in one survey per person that is going to participate. Next, I would like to go over some logistical matters before we get started. The phones will be muted for the duration of the webinar to avoid any unnecessary distraction. For the Q&A, as always, we'll use Slido platform at slido.com. You need to open it in a browser window and enter ESIG 17 as an event code. You'll see this information in the chat now. You'll see a thumbnails button, thumbs up, sorry, button next to questions on Slido, and you can cast your vote for if you're seeing a similar question to what you wanted to ask, and this helps us to prioritize. We'll save about 10 to 15 minutes at the end for Q&A, and then we'll wrap up at the top of the hour. An email link with the video an email will go out with a video link once we had a chance to process it. We'll also provide short responses to all unanswered questions after the webinar. So please, if you have a question, ask away on slido.com, and event code is ESIG 17. Okay, so today's webinar is a little bit different from our regular monthly ESIG webinar series. With this webinar, we are kicking off our new ESIG large task force. It's bigger task force than what we normally have. It has a lot of work streams that you'll hear about today, and this is why we thought it grants a webinar. Large loads such as artificial intelligence and other data centers, hydrogen production facilities, EV fleet charging centers may present new challenges for electric power industry. Utility planners face difficulties in forecasting demand. Transmission planners struggle to build infrastructure at the required pace. And system operators must address grid stability risks caused by new large loads disconnecting during faults. Meanwhile, large load developers also grapple with slow and complex interconnection process, stringent reliability requirements, and limited access to wholesale markets and real-time pricing. So to address these challenges, ESIG is launching this new large loads task force to unite stakeholders, identify practical solutions, develop harmonized practices that ensure reliable and efficient grid integration while supporting industry growth. The U.S. Department of Energy, Office of Energy Efficiency and Renewable Energy, as well as Meta, are helping us to fund this effort. So the event agenda you are seeing now on your screens, so it includes open remarks from ESIG Large Loads Task Force Chair, Sam Morris from ERCOT, and the webinar then cover the scope of ESIG Large Load Task Force with 8 specialized project teams. Each will be introduced by the respective project team lead. I will then follow up with a few logistics for the task force, and then we'll switch to Q&A. All right, so just as a short reminder, once again, please use Slido on slido.com with event code ESIG17 to ask your questions. And without any further ado, let's go ahead and get started. So Sam, I turn it over to you.
All right, thanks. So, yes, I'm Sam Morris from ERCOT, kind of chairing this group. Welcome. The next slide, please. We'll start into kind of why we're here. And, you know, when we really look at it, the Large Load Task Force is we're looking for it to become the place to collaborate, right? Talk about the issues that we all have with this and kind of look at how the different types of loads, how the different geographics of the loads, how that affects our grids and how we can actually help each other to better understand how this is all going to come together. And we're looking to kind of bring people in from across the industries, basically from the ISOs, RTOs, LSCs, all the way across, and even try to engage with the developers of these large loads as well. So that's kind of why we're here. And again, I'll give the acknowledgement, you know, that Julia gave earlier, which is, you know, this is kind of being bolstered by the Department of Energy, Office of Energy Efficiency and Renewable Energy, and Meta. We'd like to thank them all for helping with this effort. And with that, I will turn it over to Julieta.
Thank you. And can we advance to the next slide? Hi, everybody. I'm Julieta Giraldez. I lead integrated planning at Electric Power Engineers. We're an engineering consulting firm and very excited to be part of this initiative. If we go to the next slide, I will be leading 2 work streams. This first one is on data collection, and it's meant to really focus on collecting data directly from the large load developers and inform all of the other work streams that you're going to be hearing today. So we will be coordinating with all the other subgroups and work streams on the requirements for this task, but we envision to be something along of the lines that are described here. So a first group of data related more to the long-term planning and the forecasting, so siting drivers, load profiles, flexibility, co-location, etc. And then the second group of data will be tailored more towards detailed modeling for grid planning, reliability, and interconnection. And as I mentioned, the focus of the engagement here is really going to be with the large load developers, the customers themselves, with input from all of the other stakeholders too. If we go to the next slide, the second work stream is going to be focused on load forecasting. So we will be leveraging a subgroup that was formed earlier this year as part of the ESIG long-term load forecasting task force that I've had the privilege to lead in 2024. And we will be tackling really more sort of the standardization of around how we communicate around the large loads, the forecasting practices, informed really by the data collection effort too. And also considering, discussion and best practices around speculative requests and the certainty levels of projects. And in this work stream, we will have engagements from experts that have already been discussing this in 2024 at ISOs, utilities, but as I said, also informed by that initial data collection and engagement with the customers and the large load developers and designers directly. And I think that's all I have. So I will pass it along to Kyle.
Thanks, Julieta. Hi, everyone. My name is Kyle Thomas. I'm Vice President of Engineering Compliance Services with Elevate Energy Consulting, and I'm going to be supporting the subgroup on the large load interconnection process with this. And I look forward to working with everyone in the industry with the ESIG and subgroup team leads here as well. Next slide. So fundamentally, this subgroup is really focused on working to improve the large load interconnection processes at both the transmission and the distribution level to kind of fundamentally create more efficiency in those processes, more streamlined activities, standardize them where possible, and really create milestone entry processes overall as part of these large load interconnections. Importantly, we're considering both transmission and distribution aspects as part of this subgroup, as we see certainly very large transmission directly connected loads and facilities, but we're also seeing a large amount of aggregate distribution connected resources or loads to that level. And so both of those aspects need to be considered and standardized where possible between the two, owing to the differences between both T and D levels. So throughout this subgroup, we're going to really focus on looking at what's working today, what's not working today by doing some industry surveying of load interconnection processes around the country, finding out what gaps and what issues are various entities at ISOs, RTOs level and utility levels dealing with these large load interconnection processes. Where are those inefficient processes, and what's leading to highly speculative projects moving forward? What we're hearing in the industry at large is that sometimes project applications can be as simple as an email with no entry fees, no milestones, no site control, and that type of thing. And that's a main driver of some of these problems that could lead to large queues, inefficient processes, and a lot of work with all parties in the industry without having these kind of process improvements overall. From that work, we want to develop recommended interconnection processes for large loads, having key milestones and checkpoints and entry fees and other milestone fees throughout, from very beginning of the submittal of an application all the way to commissioning and energization. In addition, importantly, working with the other subgroups, there's a lot of checkpoints between all the different subgroups. So I'll look forward to working with them all through these different activities. But what information, what data, what models, and what studies are needed throughout those large load interconnection processes at both T and D levels throughout that whole life cycle of the process. We'll do some heavy coordination with the other topic areas throughout this, but that process is informed by the actual stages, but also what checkpoints and what information, what green check marks are needed before moving on to the next process overall. In addition, we are seeing a tremendous amount of activity in this large load space in the industry. Almost daily, there's some sort of new activity, new announcements, partnerships being formed. So what unique processes in these large load interconnections are needed between these T&D interconnections, and also between the different types of arrangements that we're seeing. Like I said, bulk connected facilities connecting to transmission, but also the aggregate side, also the behind the meter, front of the meter, flexible versus non-flexible, really detailing those out and how the processes may need to change or not, corresponding to these types of unique aspects of these large load facilities that we're seeing across the board. Overall, we then want to provide those recommendations, lessons learned for large loads on what we've learned from the IBR world, the inverter-based resources. We've learned a lot through the interconnection of IBRs over the past decade or more, including that first quarter 2023. So what can we learn from that world and apply it here to the large loads? And it's timely because there's so much activity in the industry with the IBRs that we've learned a lot and improved a lot. And what can we do there to apply it to large loads as well? Next slide. So for a call for help and the expertise here, we're looking for those interconnection engineers, project managers on both the customer side, the large load developer side, owners and operators there, and of course on the ISO, RTO, utility side that are dealing with these large load interconnections at the transmission level, but also importantly, the distribution level. Importantly, also, there are heavy regulations involved here, both at the state level and at the federal level, corresponding also with NERC experts as well. So anyone that's got that aspect of where are regulations in place today for these large load interconnections and those lines between them would be really critical help here throughout this subgroup. And similar to Julieta's comments there before, those large load facility owners, operators, developers, the engineers, the project managers involved in that. And a key aspect is that grid interface and those electrical designs of those facilities really come into play in some of these process steps as well, especially in the models and such. Utility large load business development personnel and key account personnel that deal with these relationships and these processes on an ongoing basis. Of course, third-party consultants that work with all the above stakeholders, and then personnel at ISOs, RTOs, and those utilities involved in this process at any stage are critically important, and we look forward to working with you all on this subgroup here. With that, I think I'm now passing on to Ahmed.
Hello, good afternoon, everyone. I'm Ahmed Rashwan, Director of Transmission Planning and Operations at EPE, serving our utility client segment. Really excited to talk to you all today about load interconnection requirements. It's something that's been top of mind across the industry, both for the folks in planning, but as well for those in operations who are preparing to welcome these loads onto the system in reality. So we can go to the next slide. At a high level, I think what we're looking to do is catalog the behaviors that are impacting reliability today. So we've heard about ride-through, variability, predictability, ramp speed, controllability, and really the goal here is to understand what can be expected and if there are any changes that we need to make to current planning processes to account for some of the behaviors that are currently not considered in load planning studies. We also want to take a look at the system events that have occurred. I know ERCOT recently shared several deep dives into events that have, I think about 14 events at the NERC Large Load Task Force, which was really interesting. And I guess my takeaway was some of these large loads are very, very sensitive to voltage. There was widespread loss of various types of large loads. And so with that in mind, we want to understand in detail with whatever high granularity data we have available, what those behaviors are, what the triggers are for the load coming off, and kind of consolidating that into a set of observations. Next up, we also want to build a compendium of existing international low performance requirements. Europe has been dealing with this for quite a while now, and I know Julia's kind of been at the forefront of some of those discussions. And so what we're going to be doing is building kind of a data set that identifies what current performance requirements exist and if those are transferable over here into North America. We do really want to engage with the large load community. I think there are some expectations on our end that are typical of utilities, understanding, we want to ride through everything. We want to understand, have more control, have more visibility, and understanding of what the future looks like. But we do want to reconcile that with the actual behaviors and capabilities of these different large load facilities. So conversation with the large load developers is going to be a big part of this, so we can understand which bridges we need to, what we need to bridge in terms of requirements. And lastly, with all of this in mind, our ultimate goal is to develop an interconnection requirement set for large loads. This is not going to be an easy task. It's certainly a tall order, and we're really looking forward to tackling it together as a group. As Kyle mentioned earlier, we're dealing with a varied population of sophistication when it comes to large load interconnections. At EPE, we've seen folks who have land and they see wires in the back of their land, and they're kind of wondering how much load they can serve on that property, given how lucrative it's going to be over the next while. And on the other side of the spectrum, there's certainly hyperscalers who are much more sophisticated in their understanding of the utility industry at large. So definitely looking forward to coordinating with a varied group of representatives. And so with that engagement, we're going to be looking to speak to the typical ISO RTO segment, transmission and distribution utilities. I think large load developers, but very important for this particular stream, a little bit of a differentiator is going to be large load facility designers, getting into the nitty gritty and understanding what equipment is capable of riding through, what performance requirements we could reasonably put on folks that wouldn't be unduly restrictive, and certainly regulators as well in that mix. So that's everything for me on this one. I'll pass it on.
Can anybody hear me?
Yes, now I can.
Okay, great. Well, thanks, Ahmed. Hello, everybody. My name is Parag Mitra. I'm a principal technical leader at EPRI, and I lead a lot of our work here on dynamic studies, modeling required for dynamic studies, long-term transmission planning. And very recently, we have been doing quite a bit of work around how to account for some of the reliability challenges that we are seeing with large loads, and Ahmed kind of spoke a little bit about that. So I'm going to lead this particular piece of work, which is around the modeling requirements for interconnection of large loads. And if you see what modeling is, right, it's essentially trying to create some of these models for large load facilities that then you can use in your simulation studies to identify beforehand the kind of risks that might exist on your system. And then during your ongoing studies, these models are necessary for you to sort of understand if and how you can sort of face some of these reliability challenges. As Ahmed mentioned, some of these loads tend to have behavior that we have not dealt with before. So let's move to the next slide here. Okay, so how do we want to tackle this particular challenge around the modeling of large loads? And just to preface this a little bit, modeling of loads is not a new concept that the industry has to deal with. We have sort of looked at this in the past as well, and there is a lot of active load modeling working groups. NERC has one, notably WEC has one, and there are other organizations that have load modeling working groups within them. The challenge, though, is that a lot of these emerging loads, they are quite different from the existing large loads that we have on our system. So if you compare a steel mill with a data center, you can clearly start thinking about the differences that exist. We are moving away from large motors, and now we are seeing large rectifier connected loads, and they tend to have very different behavior. A lot of them are very voltage sensitive, right? So the existing models that we have, they are not great to model a lot of these electronic loads, considering that they were developed to really model consumer electronics, so things like computers and television sets that we have in our houses, right? So how do we want to go about tackling this particular challenge? Well, we are going to tackle this by looking into some of the overview of how we want to model some of these loads and how these loads are kind of different from the existing loads. I think it's important for us to, as a group, really look into how these new loads are different from the existing loads and why some of the existing models cannot be extended and why there is a need for modeling. So we are going to set some of those things. Then we are also going to look at some of the existing modeling practices and how we want to evolve those practices with these new large loads coming onto the system. And there is something that is kind of new over here. In the past, a lot of these modeling requirements, if you followed some of the NERC requirements that exist in North America, they were only limited to the generators on the system, and a lot of the load models were actually developed and submitted by the transmission providers, the transmission owners, based on some empirical knowledge of what those loads look like. And we had some rules of thumb, and that was considered sufficient. But with these large loads, now we're seeing that type of approach is probably not sufficient, and we would probably need to get some of these models through some of these interconnection requirements and use these models. So we want to focus on how these new modeling needs changes and how we should start thinking about how that practice evolves. Then there is also this piece of how do we even model these large loads, and there are a lot of questions around it. It is not as clear as what we do with inverter-based resources, although there is a lot to be learned from there. We have looked at large wind farms, large PV plants, and we have seen how we can use aggregated models for our transmission bulk system reliability studies, and we have looked into circumstances where EMT models are needed. A lot of those guidelines do not really exist for load facilities. On top of that, a lot of these load facilities, when we think about these load facilities, the folks that we deal with, they might not be directly involved in a lot of these power system studies that we discuss and we talk about. So their concept of modeling, what they're trying to understand from the models, can be quite different. So there is definitely a need of developing some guidelines around how these models need to be developed, what is important for a transmission planner. We don't want to get into the details of everything because we don't look at everything. We are transmission planners, we are grid planners. We want to understand the necessary information that is required for us to sort of identify what these issues are and what these issues that we're going to face. Then there is also this question around model quality tests, not just developing model guidelines, but when models are submitted, one has to understand whether these models are actually sufficient for their study. So there should be some quality requirements around these submitted models so that one can understand whether these models are good enough to be used for the reliability studies, right? If we can run simulation studies, if the models are garbage, then the results are garbage. So there needs to be some protocols over there. And there is some work that is being done over here because of IEEE 2000, and folks are talking about model quality tests in the context of inverter-based resources. We are going to look into some of those guidelines and see how or which parts of those can be taken out and may be applicable to some of these large load facilities. We want to do some demonstration to highlight why these models are important, what parameters are going to be very much consequential. So you want to run some case studies to demonstrate, given that there are a whole host of things that you want to learn, and the reality is you might not get a good picture of all these parameters that need to go into the models. The question there is that which are the ones that are most consequential and you want to identify. So we are going to do some demonstration through case studies where we want to demonstrate why a properly validated and parameterized model is necessary. So we want to do some of those things there. And then the last thing is to develop some recommendations. Out of all of this work, what we want to do is provide the industry some recommendations around how they want to go about all these modeling activities, how they should be changing their interconnection processes, what are the models that are absolutely required from the vendors, when they should be requesting phasor models, when they should be requesting EMT models, or they should be requesting both of those models, right? So a lot of these recommendations I'm expecting is going to come out of the work that we are going to do over here. Let's move to the next slide here. So who all should be joining this particular task force? It's generally the folks who are running all these dynamic studies on the transmission planning side. So transmission planners, operators, ISOs, folks who are working on dynamic simulations, folks who are responsible for integrating all these models into the system and running the studies. They should be involved in this particular work stream. The other people who are very much needed in this particular work stream are third-party consultants who are working with data center owners who are developing these power supply systems, because a lot of the things that they put into or that they program into these UPSs and these controllers are something that we want to understand and we want to capture in our models, because they are very much relevant in terms of the model's performance and what we learn from these models. So I would encourage all of you to reach out to me, and then happy to have a lot of heads in this particular task force, and then get some good work out of this. So that's all from me, and we can pass it to the next person here, Eric.
Thanks, Parag. Good afternoon, everyone. My name is Eric Ela, and I'll be supporting this project team on wholesale electricity market design, market operations, considering large loads. One way to think about this this STEM this work stream is really thinking about all the other work streams that are sharing information about what the impacts of large loads may be, what types of investments, what types of characteristics or behavior from those large loads might be beneficial, including the ability to be flexible, to adjust output, to adjust other things to help the grid. And what we'll want to look at through here is, are there sort of the right incentives to do all of that, to have the that behavior match what we see as desirable. So in the next slide, talk a little bit about what we're planning on. Of course, try to gather that input from the folks that are interested and are participating and sharing that input when we get started. Done a lot of work around participation models for other technologies, including existing demand response participation models. Really, what is the way that these resources interface with the wholesale markets, including eligibility for different types of services, what types of parameters are provided, literally the model that's used in the market clearing software, and other aspects, and seeing, what's the right way that these large loads can participate, and whether there's encouragement to participate more actively than maybe we see with most loads that do today, and what that participation model might look like. With that, going further into the different types of auctions, the different types of products that exist in wholesale electricity markets. So obviously focusing on energy markets, but also ancillary services, whether that flexibility can actually be used within ancillary service markets, whether they can provide different types of operating reserve and other types of services, as well as the capacity markets. And what does it mean for large loads to impact what the capacity market need is, or contribute to that? Of course, that will link very closely with the resource adequacy work stream there. Another key focus we'll have is just trying to understand what participation looks like. So perhaps working with the data work stream, gathering information about what type of flexibility there is, how can that be offered, what's sort of the price sensitivity of different types of large loads, when does that differ by time of day in different locations, looking at things like the spatial flexibility, and how does that translate into the participation with the market, and what types of offers are provided. Gathering some of that data and perhaps looking at surveys of sharing that with the broader industry. Lastly on here, and I'll say this topic is kind of has it fit into this work stream, but of course, and I've seen a lot of questions on the Slido already about it. It will be something that will span across multiple work streams, but I'd say looking at the different configurations of large loads and how those can impact that market participation. So obviously one that we look at a lot recently is the large loads co-locating with large generation resources, and some of how that impacts the participation, and looking at what types of costs are associated with those different configurations. Not really diving deep into things like cost allocation itself, but looking at a survey of how this is done in different regions, and sharing that information without necessarily providing recommendations on how to. That's very much a policy decision, but kind of focusing on some of the what's existing today, and sharing a survey across different market regions, for example. And of course, getting some information from folks that are interested in participating in the program, in the work stream, to share some input on what other topics or goals they might have related to the markets, wholesale market design and operation side. Next slide. So just in terms of the participation, see a lot of folks here, great participation that we have today. Types of folks that I think would get the most value out of this project team, and that could contribute substantially are those that I'm showing here on the slide. Of course, ISOs and RTOs that are very much responsible for the wholesale electricity markets themselves, and overseeing the software, overseeing the designs, overseeing the different auctions and different products. Folks from the energy side, ancillary service side, to the capacity market side, and everywhere in between, of course, is an important stakeholder. These suppliers, so essentially those that are supplying energy to those large loads, that includes utilities, it includes independent power producers, it could include these different configurations, including those that are co-locating with the loads, but basically those that are supplying energy to the large loads, that would have that would find a lot of importance into some of the discussions that we're having here. And then the large load operators themselves, those that are coordinating how those large loads are participating in the market, or how they're impacting, and how trades are being shared within the wholesale markets. Folks that have some of the knowledge on how flexibility is being provided, how flexible those resources are, as well as their consumption profiles, how sensitive they are to prices and things like that, how they might actually participate in getting that information. Regulators, primarily looking at wholesale regulators, and not just in the United States, but also potentially other places around the world, but also state regulators and folks more on the retail side. I think obviously there's a lot of interaction across wholesale and retail. Even though our work streams focus on the wholesale side, I think there's a lot there that can be provided as input as part of those folks that participate. And then really, sort of anyone else that has this expertise, has an interest, that can share useful pieces of information, and participate in the discussions, particularly folks doing work, helping those entities that are listed above, those on the research side that are conducting research around large loads, and anyone else that has a strong interest around the market participation of large loads. And as I mentioned, I'm leading this this project team. We'll probably be looking for potentially some other folks to help with a lot of the writing, with some of the facilitation as well. But definitely encourage anyone interested in the project team and potentially have a larger role to reach out to me, reach out to Julia or others, and to let us know. All right, thanks all. I think we'll move on to the next project team. Hannes.
Thank you. Let's briefly talk about transmission planning, or the transmission planning portion of this effort. Next slide, please. So the focus would be on how to develop a proactive, holistic, and scenario-based transmission planning process to support the more timely, flexible, and cost-effective integration of large loads and associated generation. Obviously, the way transmission is planned, if it's planned proactively, it will make load interconnection and generation interconnection processes much more smooth, more quick, and more cost effective. So the way to go about this would be through several steps. The first one is to just look at current processes and how they're used for transmission load, large load generation and generation interconnection process, and identify any best practices we can see from that. And here the best practices would really have to focus on not just long-term transmission planning for the next 20 years or something, but also transmission planning that includes load interconnection and generation needs, along with other transmission needs, in order to create more cost-effective, more timely solutions. We would want to show how scenario-based planning, as it is used in some places, like Australia, for example, can really be used to identify the highest value, least regret solutions that are also flexible enough to respond quickly to changing needs. As the future is uncertain, and now with large load interconnection, it's not just that the long term is uncertain, but even the near term, the next 5 years are uncertain. In that kind of uncertainty, planning is more difficult, but it also is possible, and it is possible to create solutions that can deal with the uncertainty by being more flexible. Grid enhancing technologies will have to play an important role in this, just to maximize existing infrastructure, not just from a cost effectiveness perspective, but also from a speed perspective, because often grid enhancing technologies can be deployed much more quickly than either upsizing existing transmission lines or building new transmission lines. And finally, we will have to develop actionable recommendations to achieve the benefits that proactive and holistic planning can provide for this specific purpose. Next slide, please. So if you're interested in that topic, who should join? Certainly transmission planners at the ISOs, the RTOs, the utilities, large load developers who have expertise in project sizing, siting timelines, the uncertainty, and who might have been frustrated with certain transmission planning processes or impressed with processes in other regions that seem to work better. The large load operators, so of having a better sense of what the cycles of site developments and scaling up large loads might look like. This is an issue for regulators, of course, not just regulators involved in transmission planning, but also involved at the state level, since these large load interconnections will or can have implications on retail rates in the state. And then, of course, technology experts, particularly for grid enhancing technologies and advanced planning tools. I will co-lead this with Warren Lasher, who you all probably know. He used to be at ERCOT for many years. And with that, let me hand it over to the next group.
Great, thank you, Hannes. My name is Derek Stenslick from TELUS Energy. I'm going to be leading the resource adequacy component to this task force. And as many of the folks said, there's a lot of overlaps, especially with some of the scenario planning that Hannes just mentioned and the market design and operation that Eric was talking about, as well as interconnection and load forecasting. So a lot of interplay here. I'll piggyback on what a lot of the folks already said. If you go to the next slide, please. What's specifically in scope for the resource adequacy component? I broke it down into 4 pieces. There's certainly more, but these are the broad categories I was thinking about. The first is really around differentiating large loads. We know the use case, the characteristics, hourly, seasonal demand profiles. We know all of that's going to change depending on what the large load looks like, and kind of further segmentation. Even within data centers, there's going to be differences. We want to know about the price sensitivity of those and really the flexibility options. If we need to curtail the load, or if we want to curtail the load from a reliability perspective, what's on the table for that? And so that's really the second piece here, is really digging into the flexibility options. And again, that's going to be different based on the large loads that are in scope, and even different within data centers. So really, as adoption starts to increase, what are the opportunities for flexibility? The third is around resource additions. We know a lot of these large loads, or the majority of these large loads, are also bringing generation or some sort of capacity to the table as well. Sometimes that's co-located at the same location. Other times it's contracted across the broader region. And so what does that feedback loop look like? And with all of this, as we start to evaluate these from a resource adequacy component in our loss of load expectation, or fundamentally driving the capacity needs, we want to have that feedback loop in there and understand not just the load impacts of these large loads, but also the generation they're bringing. There's differences, whether that's time matching, and we're actually getting 24/7 matching of the generation, or if it's just annual kind of true up of the generation. And so really understanding the contractual piece of this as well. And then just uncertainty. So again, this dovetails really well with Julieta's load forecasting component. But how do we manage with the uncertainty around these loads in our load forecast and in the generation planning that goes along with it? So in our capacity markets and in our IRPs. Next slide, please. So I've got a figure here, not enough time to go through it, given we want to have some discussion. But the real question here is, if a resource, if a large load is flexible, and if it brings its own capacity, are these large loads beneficial to resource adequacy, detrimental, or net neutral? That's fundamentally the question. So there's some good scoping work that was done in this space, and there's a link there. But if you go to the next slide. So key objectives and research questions, that again, do large loads have beneficial, detrimental, or neutral impact on resource adequacy? Really all comes down to the flexibility component and the capacity that these resources are bringing to the table. So if the resources or if the loads are flexible, how much flexibility is required? Like, how many times would it be called on in a given year? How long of a duration of a response would we need from a resource adequacy component? And that's going to be different both today and in the future. So really trying to spec that out, or to characterize that, so then grid planners can go to these large loads and say, well, this is the type of response that we would be looking for in order to promote resource adequacy. Recommendations on, so a component is kind of answering that question, that first question, are these beneficial, detrimental, or neutral? It's kind of a billion-dollar question now. The second is for the grid planners out there, like, how can we best model these resources in the resource adequacy models? Is it just a fixed load every hour of the year? Is there an hourly profile, a seasonal profile? And then how do we capture that flexibility and the resource additions that go along with it? So one part kind of answering that research question, one part recommendations for the modelers out there. If you go to the next slide, kind of started to spec out what this is going to look like over the next kind of 6 months, broke it into several different topic areas, from segmenting the load to understanding the flexibility, thinking about the PPAs and contracting that go with the generating resources, model recommendations, kind of the net impact, answering that question, are these beneficial or detrimental to RA? And then finally, what I'm kind of grouping together is regulatory or market design question. Again, a lot of overlap with some of these other groups, but specific to resource adequacy, how can we promote that flexibility that we know we're going to need? So in terms of who's involved or who we're looking for, consortium here of industry leaders around grid operators, utilities, researchers, regulators. That's kind of the typical space in the resource adequacy. What we're really looking for to augment a lot of the work we've already been doing in the RA space is talking to operators and developers of the large loads. And that includes data centers, anybody working in the electrolyzer hydrogen space, or fleet electrification. And again, really, if I were to make it even more specific to that, people that really understand the flexibility potential of these resources, not necessarily where they want to be in terms of flexibility, but what could we get out of them if we aligned interconnection and incentives correctly. Next slide. I believe I'm passing it over to the next speaker.
Thanks so much, Eric. We can go to the next slide. I'll just take a few minutes to cover the logistics, and hopefully we can get to some questions in Slido. So as I mentioned at the beginning, participation in ESIG task forces is limited to ESIG members. However, as with all of our reports and final publications, all of that will be publicly available on ESIG website and will disseminate through future workshops and webinars. All current members for ESIG can be found on esig.energy. If you go to membership at the top menu, you can see which companies are ESIG members right now. And if you are an employee in this company, you are a member. So it's a company membership, includes everybody in the company. If you would like to join ESIG, please contact us after the webinar. Just go to our webpage and click on Contact Us at the top menu. If you are interested in actively participating in the ESIG Large Loads Task Force, please complete the survey and select key areas that are most relevant to your expertise. You can choose more than one, but have each person that wants to participate fill in their own survey. That helps us to compile distribution lists for each project team. Next slide, please. If you are familiar with ESIG and you are wondering how this task force sits with the rest of our working groups and task force structure, you can see it here. So kind of working groups are on top and left here, and this task force relates to reliability working group, system planning working groups, system operations, and market design working group. And then a large task force will span through all of these three working groups, and different topics will fall under different working groups, but also, or under different working group scopes rather, but also there will be a lot of collaboration between the groups because as the project team leads identified already, there is a lot of interrelationship between these topics. Additionally, there is kind of complementary effort to this one that Lawrence Berkeley National Lab will kick off, and they will be focusing on regulatory and contractual aspects of large loads integration, including rate structures and things like that. And so they will run it through LBNL. Next slide, please. So just how it's going to work together. After this webinar, we'll give it maybe another week before Christmas for people to fill in the surveys, and we'll compile distribution lists for each of the project teams based on this survey. Project team leads then will reach out to their respective teams with more information. Basically, the idea is that project teams on each of these work streams that you've heard about today will meet separately, but also may have joint meetings as they go ahead and based on the need. Project team meetings will include stakeholder presentations, but also structured discussions to get to some kind of recommendations at the end of the project for each of the project teams. Each of the project teams will take 8 to 16 months to conclude. They will all run in parallel. Data collection and forecasting project team will need to be a little bit ahead of everybody else because a lot of this data collection information will feed into other working groups, into other project teams, sorry. And then if you're wondering, as a project team member, what you're expected to do, it's basically up to you to decide how to engage. We're, of course, looking for active engagement. So engage in discussions, share relevant experience. You can offer to deliver presentations during meetings, provide references, or share some information during the discussions. You can volunteer to contribute to report writing. You can just listen and learn if you're new to the field and you're just interested to understand more. And then you can also review the draft report and provide your comments once the report is ready. We can go to the next slide. And finally, just another thing, ESIG Large Load Task Force will organize 3 workshops during the course of 2025. And these workshops both will inform the project team's work, but also will disseminate the results that will be available at the time from the project teams. So the first workshop will be held during ESIG Spring Technical Workshop in Austin on March 20th, and will be focused on all 3 things related to reliability impacts of large loads, so interconnection process, interconnection performance requirements, and modeling requirements. So these are things that Kyle, Parag, and Ahmed were talking about in the beginning of the webinar today. And then during summer workshop, during our markets and forecasting workshop, we'll have another one potentially focused on data collection and load forecasting, wholesale market options, and resource adequacy, realizing that all of these themes are interrelated. And then during our fall workshop, we'll have another workshop around this large loads task force focusing on transmission planning. The 2 other workshop topics, so during summer workshop and during fall workshop, is something to be determined yet. We'll see how the topics relate together and what makes most sense and how to combine them. Next slide, please. So with that, we'll go to Slido. We'll spend maybe 5-7 minutes on questions, and then, as we said initially, we'll send a recording, and we'll also answer all unanswered questions offline, and we'll send you the Q&A combined. All right, so the first question is, and maybe, I see all the panelists here. If you would like to chime in and answer, just raise your hand and I'll be able to see. The first question is from Mark. The data center industry tends to be secretive in terms of specific approach to facility design. How can we as a group, overcome this tendency? Anyone wants to take it? I guess it's maybe to Parag, a bit more on interconnection requirements as well.
Yeah, I can make a quick comment on it. So one of the reasons why we don't get that information, or why folks are not willing to share that information, the 2 reasons. One is they're not required to. The second one is it takes time and effort to provide information that is relevant for things that we do in our assessment, right? So one of the things that at least we have realized right now is that style of connecting loads that we did in the past, where majority of the requirements were sort of narrowly limited to power quality, is going to be a challenge as we move into the future, where these loads are significantly large in size, right? So there needs to be a shift, and one of the key things that at least I expect to come out of this particular working group is an understanding, and that's probably why we want to have folks from both sides, even for them to understand that, look, you're large enough that you doing something is going to affect the supply quality that you get yourself, right? So for a load to be connected, they need to be open about certain things. They need to provide certain things that a grid planner needs to understand. So it is an evolving space. So we see where it goes.
Thanks, Parag. Ahmed, I can see your hand up. Maybe briefly.
Yeah, I totally agree with Parag. And I also wanted to add that, Julia mentioned one of the sponsors today is Meta. And so what I'm really encouraged by is that we actually have the data center community engaged with us at the last ESIG session in the fall. we had a representative from the data center community come up and ask, how can we be part of this journey and getting everything connected and understanding how this can be done in a way where data centers are not the main focus of challenges on the system. They want to play ball. So I'm pretty excited about, the opportunities that this task force is going to present and working alongside kind of the developer community throughout.
Yeah, thank you. Thanks, Ahmed. And one thing I wanted to take up, it was kind of a theme through some of the questions. First of all, asking about how this relates to other ongoing task force activities. So there is a NERC task force kind of focusing on some of the similar topics. There is a big project at EPRI, also focusing on large loads. So short answer is we're all aware of each other's task forces. We're going to coordinate. Scope and breadth of each of these task forces varies. So I feel like we're covering a lot of ground here. So there is an overlap between, say, reliability related topics here and NERC large loads task force as well. One other thing I wanted to mention, overall ESIG over the years and historically kind of creates this safer space for discussion, kind of open discussion of topics where we don't have solutions yet, where we are not yet ready for reliability guidelines or standards to be developed right away. So this is to prepare the ground to have this productive conversation first, from all stakeholders, understanding needs of all stakeholders, but also capabilities and limitations. And once we kind of, talk through this, figure it out what the best practices is, there, of course, will be ongoing work with NERC and other involved parties to kind of put it in standards or, create requirements as needed. So that's just to cover the space. I'll take maybe a couple more and then we'll conclude just to respect everybody's time. The next question is, how do we quantify the risk of large loads not materializing? Is there a risk of overbuilding to meet an uncertain long-term load forecast? So I guess this is to Julieta and maybe to Hannes.
Yeah, no, that's a very good question. I think that's absolutely what scenario-based transmission planning has to sort out, how to minimize the risks of either underbuilding and regretting to not have added more capacity, or overbuilding and creating stranded cost. That's why, there might be a premium on flexible solution, such as, building new transmission lines that can operate at higher voltage that could be converted to HVDC lines. But I also think that this whole planning process needs to sort out very early on how much of the new load is supplied by the grid versus how much comes with its own generation, co-located generation. I mean, obviously, if you have a gigawatt data center that comes with its own generation, that's a very different implication for grid planning. You wouldn't want to plan as if that load doesn't have any of its own generation, and then charge extra for the generation as if there wasn't any load. So I think we need to, both from a planning perspective, but also from an interconnection planning and operational perspective, deal with co-location, because that will have major impacts on grid planning and could potentially create a risk of oversizing.
Thank you, Hannes. I think I see people dropping off because we're at the top of the hour. So to respect everybody's time, I would like to just close out. Would like to thank everybody that came to this large load task force kickoff meeting, and also to the project team leads that introduced the focus areas and responded to a few questions. As I mentioned earlier, an email will go out once the video file has been posted. We will get responses to all your unanswered questions as soon as possible. An email will go out with the compilation of the short responses. So you'll see that. I think some of the questions are actually already feeding into some of the project teams. So this is very productive. If you are interested in joining Large Load Task Force, please fill in the survey, post it in the chat. Note that Large Load Task Force is a member-only activity. If you're not yet ESIG member and would like to join, please follow up with us after the webinar. We'll process the survey results in the next few weeks, and you'll hear back from us, from the respective project team lead, about the next steps. This was the last ESIG webinar of the year, and I would like to thank you all for your participation today and over the course of the year. We wish you all happy holidays and look forward to seeing you in continued engagement with ESIG, including this Large Loads Task Force in 2025. And in the meantime, everyone, take care and stay safe. Goodbye now.